Hello dear students, welcome to my channel. We'll continue with the chapter number 5, geography, that is temperature. Can you tell? Find the range of temperature at Mumbai, Nagpur and Srinagar and then draw the bar graph for the same. First of all, let us understand what is range of temperature. The difference between the minimum and the maximum temperature during a day of a place is called as the range of temperature. So we'll first of all see what is the range of temperature in these three cities and then we will plot the bar graph. Suppose the minimum temperature of Mumbai is 20 degrees, maximum is 32 degrees, that at Nagpur is 22 degrees and maximum is 44 degrees. Srinagar, the minimum temperature is 2 degrees and maximum is 24 degrees. Let us plot in the graph. Here you can see the graph is being plotted. On the x-axis we have shown the cities, on the y-axis we will be showing the temperature in degrees Celsius. In brown color we have shown the minimum temperature and in red-green color combination we have shown the maximum temperature. You will see that the difference between the minimum and maximum temperature is very much in Srinagar as well as in Nagpur. So these two cities will be having extreme climate, whereas Mumbai, the difference is not that high. That is, we can say that the climate of Mumbai is equable. Climate of Nagpur and Srinagar is extreme, whereas that of Mumbai is equable. Now the next part is, what will you do? You stay at Man in Satara district. Your grandmother stays at Vengurla in Sindhudurga district. During Diwali, you often visit Vengurla. You like the sea coast there. The warm air of that region attracts you because you are freed from the dry air and scorching cold of your place. This time, grandmother is suffering from asthma. Doctors have advised her to stay at a place which has drier climate. What should you do? The answer is here. As the doctors have advised her to stay at a place which has drier climate, I will take her to my place in Satara, Man district. Man in Satara district. The reason is, this place being in the interior, it will be having drier climate and drier climate will be suitable for grandmother. Do it yourself part. Here you can see the students are doing an activity. A pot with water is placed on a burner and you have dropped 4 or 5 small plastic buttons in it. When you heat the pot, you will see the movement of the buttons, and the movement of the buttons will tell you about the convection current that is set into the water. Let us see what is convection current. Now, as you know that water, when it's heated, it will expand. On expanding, it will become lighter. So the water which has become hot, being lighter, it will move from the base upwards in the upward direction. But the water up is still cold. So that cold water will move down and replace the place of the hot water. So hot water will be seen rising up and the cold water will be seen going down. So currents are set in this way. In this upward direction, hot water will move and cold water will move in the downward direction. Let us read the explanation. Water expands on heating. Hot water from the base moves upward. With it, the buttons too are pushed to the surface. The relatively cold water or cooler water in the upper portion moves downward, taking the buttons with it. This happens repeatedly. In other words, on heating, an upward current sets in the water. In nature, the conditions are slightly different. The water might be moving upward or it might be moving in the horizontal direction in nature actually, because hot water and cold water may be at different places. Here, since you are heating the water in the pan and it is receiving heat from the burner, The water at the bottom got hot, the upper water was still cold. But in nature, water at one place may be at higher temperature than the water at other place. So water at a higher temperature, that water will set into motion and move to the place which is at lower temperature. So horizontal currents will be setting in. Now the factors which gives rise to this horizontal current mainly is a temperature difference. Other factors are wind, and the next is difference in density. Let us see these factors once again. Temperature difference is one of the important factor that leads to horizontal ocean current. Other factors are winds and also difference in the density. The ocean currents, you will see in the equatorial areas, in the torrid zone, this water will get heated and the water in the polar area is still cold. So students, you must be knowing by now that hot water will be moving towards the colder area and the water at cool area will be moving towards the hotter area. So the current is set horizontally. Here the ocean currents flows from equatorial region to the polar region and from the polar region to the equatorial region. In this figure 5.6, world ocean current, you can see the dark pink lines are showing the hot current or the warm current, and the light blue lines are showing the cool currents or cold currents. So you can see the equatorial areas, as it receives perpendicular rays of the sun, the water there gets heated, and this hot expanded lighter water will be moving towards the polar areas and the current is set. The water in the polar areas will be moving towards the equatorial area. When an ocean current flows from the frigid to the torrid zone, it reduces the temperature of the coast in the torrid zone. So as the cold currents are coming towards the hotter area, they will reduce the temperature at the coast, and as the hot currents are moving from the torrid zone towards the polar zone or the frigid zone, the coastal area in the frigid zone will be having higher temperature, or the temperature in those coastal areas increases. For example, if you see the hot current, which is moving from the equatorial area here, and as it is moving up, it will keep this coastal areas of this part of Europe bit at a higher temperature. As warm currents are moving from the equatorial region towards the polar region, this particular areas of Europe, around this area, they will be having warm temperature. But on the other hand, if you see the cold currents which are moving here, as the cold currents are moving, this coastal areas will be having cold temperature as the cold currents are moving near it. After having understood about how the warm and the cold current influences the temperature in the areas where they move, we will understand what happens at the place where this warm and cold current meets. Let us see in the map. Can you see? Hot current is moving here and cold current is moving here. So the place where hot and cold current meets, okay, the place where this hot and cold current meets, there is a favorable place for the growth of planktons. So the region where warm and cold current meets is a favorable place for the growth of planktons. Now what are planktons? Planktons are the food for fishes. These are small living things on which are eaten by the fishes. Planktons are the food for the fishes. Fishes and from other areas travel towards this area in large number. Now which area I am talking about? The place where warm and cold current meets. As in this place, there are a lot of planktons growing there or planktons breeding there. Fishes from other areas will move towards this area, and as fishes are found in abundance, this area will be a breeding place for the fishes. Due to high concentration of fish population in this area, fisheries thrive well in this area. Here is a picture of showing you some other sort of planktons. Okay, small living things eaten by fishes. Now, geographical museum. There are a number of methods of showing distribution on a map. One of these is isolines. So, distribution of the map can be shown by different method. Isoline is one of the method of showing the distribution. Due to this method, the characteristic distribution of a component stands out vividly. Very clearly, because of this isolines, the distribution can be seen very clearly. Now, isolines are drawn using statistical information about natural factors. Some facts, some numbers should be there for you to draw these isolines. These isolines are drawn on the map by joining all the points having the same value. So, the places having same value are joined by these lines. Now, the distribution on the regional or the global level can be shown using isolines of different factors. For example, height is shown by counter, temperature is shown by isotherms, pressure is shown by isobars, and rainfall by isoheights, and etc. So, what are contours? Contours are the lines joining the places having the same height. Isotherms are the lines on the map joining the places having the same temperature, and so on. I hope students this is very clear. What are contours, isotherms, isobars, and isoheights? We come to very important part of the lesson. Here in the figure 5.7, you can see the world annual temperature. We come to the very important part of this chapter. Figure 5.7 shows the world mean annual temperature. I have told you that isotherms are the lines on the map joining areas having same temperature. So, this map shows areas of the same temperature being joined by the isotherms. Let us read the explanation. Considering the temperature of various places on the earth, map of global distribution are prepared. Figure 5.7 is drawn with the help of isotherms. Isotherms are the lines that connect places with the same temperature, after avoiding the effect of height. These lines generally appear parallel to the latitudes on the world map. So, these isotherms on the world map appear parallel to the latitudes. Now, you have to observe the isotherm of 25 degrees Celsius. See this isotherm of 25 degrees Celsius. Can you see? This isotherm is of 25 degrees Celsius. Okay. So, 25 degrees isotherm you have to observe. This line occupies areas close to the equator. Okay. This isotherm is very close to the equator. The shape of this line appears like an ellipse on the map. Can you see? This is not a straight line, but it is in the elliptical shape. Okay, it is forming an ellipse. The north-south spread of the ellipse is greater on the continent as compared to the ocean. In the continental area, this north-south part is greater. In the ocean, it is smaller. Once again, in the continental part, this north-south expanse of this ellipse is greater, but in the oceanic part, it is very less. That means in the continental part it is broader, in the oceanic part it is narrower. Can you see? It is narrower in the oceanic part, but in the land part it is broader. Let us continue. The isotherm lines occupy some part of the continent of South America, Africa, Asia, and Australia. It is occupying this 25 degrees south. 25 degrees isotherm is occupying areas of South America. It is occupying areas of Africa, also certain areas of Asia and certain part of Australia. A very limited portion of Pacific Ocean is occupied by this isotherm. So this isotherm basically is very less in Pacific Ocean. Can you see, only this much part of Pacific Ocean it is occupying. So this 25 degrees isotherm, very little part is in the Pacific Ocean. You will find two isotherms with label 0 degrees. So after understanding 25 degrees, what did I told you in 25 degrees? Elliptical in shape, broader in the continental area, narrower in the oceanic area, and very little part of this 25 degree isotherm is in the Pacific Ocean. Now we'll talk about the 0 degree. The 0 degree isotherm. You can see the 0 degree isotherm at two places. One is here and the other one is here. The 0 degree isotherm from the southern hemisphere is largely straight and parallel to the line of latitude. So the 0 degrees in the southern hemisphere is almost a straight line and it is parallel to the latitude. So we have seen in the southern hemisphere this 0 degrees Celsius is a straight line and it is parallel to the latitude. Comparatively, the line of the same value in the northern hemisphere deviates north and south considerably. Now let us see this 0 degrees in the northern hemisphere. Can you see this 0 degrees is not a straight line in the northern hemisphere. It is moving up and down. Okay. In the western part, in parts of Pacific Ocean it is fairly straight. Can you see the 0 degrees line in Pacific Ocean is almost straight, but when it enters the continent of North America, it turns somewhat to the north. So when it enters North America, this line is moving up, it is moving in the northern direction. Then the line proceeds, the line continues its movement. Its line continues in the eastern direction. Can you see? Then it is moving in the eastern direction. Within a short distance after entering the Atlantic Ocean, means after entering the Atlantic Ocean, all of a sudden you will see that it is moving in the northeastern direction. Can you see? The direction has now become northeastern. In this part, you will find all the isotherm lines turning towards northeast. All these lines are moving northeast. Not only the 0 degrees Celsius, but the other 5 degrees, 10 degrees, all of them are moving northeast. This is because of the warm ocean current is located in this area. As the warm ocean current, remember the warm ocean current we have seen, the ocean current which was coming from the equatorial area is moving in the polar region. So as this ocean current moves, it will also be changing this isotherm lines. Further, after entering Eurasia, after entering Europe and Asian continent, this line will move eastward. Can you see the 0 degree line on entering Eurasia? It will move eastward. It is moving eastward. Still further in the Pacific Ocean, can you see this line is moving? Now it has entered the Pacific Ocean. In the Pacific Ocean, most of the isotherm lines appear moving east as straight line. Can you see? All these lines appear straight line. The isotherm in the southern hemisphere are fairly parallel to the latitudinal lines. In the southern hemisphere, if you see, students, all these lines are straight, parallel to each other. In the southern hemisphere, all these lines are appearing straight and parallel to each other, but in the northern hemisphere, these lines are zigzag line. Now what could be the basically reason for this? In the southern hemisphere, you find it is more of ocean and less of continent, and exactly opposite in the northern hemisphere. Northern hemisphere is more of land and less of ocean. From the southern pole, from the southern pole to the Tropic of Capricorn, the distance between this line is almost parallel. From the southern pole, we are talking from the southern pole. From the southern pole to the Tropic of Capricorn, the distance between this line is almost parallel, almost equal. As the proportion of land in the southern hemisphere is limited, temperature in this part is largely influenced by latitude. Now students, you will see that in the southern hemisphere, from the polar region, that is from South Pole to Tropic of Capricorn, that is up to this much, all these lines, all these isotherms lines that you can see, these lines are, the distance between them is equal. The distance between these lines is equal. As the proportion of the land in southern hemisphere is limited, land area is very less and ocean area is more in the southern hemisphere, the temperature in this part is largely influenced by latitude. Southern hemisphere, very little land is there and more of ocean is there, so the temperature is mainly, it is influenced by the latitude. But if you go to see the northern hemisphere, I told you northern hemisphere, there is lot of land and less of ocean. So in this hemisphere, the proportion of land is greater. This affects the distribution of temperature. These effects are seen in the form of variation in the distance between the isotherms and the curves. That is why you will see these isotherm lines are very curvy. The distance is also increasing and decreasing at places. Now the last part of the lesson, the thermometer. Here you have certain questions. Can you tell? Answer the following with the help of figure 5.8. This is the figure 5.8. What is the tube of the thermometer fixed on? The tube of the thermometer is fixed on the mount. Mount can be a wooden board or it can be an acrylic or a plastic board. So the tube of the thermometer is fixed on the mount. What substance is used in the thermometer tube? In the thermometer tube, either mercury or alcohol is used. So you can see that red liquid there, it can be either mercury or alcohol. What do the figures on the scale indicate? You can see the scale there. The numbers and the small lines are shown. What do they indicate? This numbers, this scale indicates the range between which your temperature will be moving. Your temperature will be limited between this in this scale, in this range of this scale. In which different unit is the temperature measured? The temperature is measured in either degree Celsius or in degree Fahrenheit. What season does the temperature in the figure indicate? Students, you can see the temperature shown here is 36 degrees. So this must be summer season here. Can you see the temperature shown is 35. So the season here must be summer season. Now understand what is thermometer. You can see a thermometer which measures the room temperature or air temperature is shown. One more thermometer is shown here. So in thermometer, there are different types of thermometer for measuring the temperature of the air. Basically, you are using mercury or alcohol is used in the thermometer. The freezing point of mercury is minus 39 degrees Celsius and that of alcohol is 130 degrees Celsius. That means at minus 39 degrees Celsius, mercury will be turning into solid. Otherwise, till this temperature, mercury will be in liquid. Alcohol will become solid at minus 130 degrees Celsius. Now, why only mercury and alcohol and no other liquid? Why not water or kerosene or some other liquid? The reason is these liquids, this mercury, this alcohol, these materials are highly sensitive to temperature variation. Even the slightest change, rise or fall in the temperature will make considerable movement, considerable increase or decrease in the height of mercury or alcohol in the thermometer column, in the tube of the thermometer. So as this material are highly sensitive, with little increase or decrease in the temperature, they will be showing movement they will be showing in fall or rise in the column of the tube of the thermometer. Now these materials, the variation in temperature from minus 30 degrees to plus 55 degrees Celsius can be observed here. So if your temperature falls to as low as minus 30 degrees or rises as high as plus 55 degrees, it can be recorded on the thermometer. And thermometer uses the units like degree Celsius or degree Fahrenheit. Air temperature generally is measured in degrees Celsius. So the minimum temperature or the maximum temperature that you hear in the news of your place is measured in degrees Celsius, and it is recorded in meteorological department of your area, of your town. Thank you, students.